This is the Algebra 2 blended class, Unit 1, Domain and Range lesson notes video. Alright, so we're going to talk about domain and range today. This is a topic that you did back in Algebra 1. It's something that's really important in Algebra 2, so we're going to make sure that we really understand that interval notation that we practiced before this lesson, so that we can find domain and range from graphs. So the definitions of domain and range are as following. The set of inputs, the things that go into a function, those are your x values, that's called the domain of a function. The set of outputs, which is your answers or the y values, are called the range. Okay, so the x's or the inputs are the domain, the y's or the outputs are the range. Now there are two types of notation or ways to write domain and range that we're going to use in this course. The first one is interval notation. This is what you were doing on that kind of mini lesson before this set of notes. Interval notation are the ones with square brackets. So like 2 to 4 has 2 square brackets. That would be an interval. Or you could have negative infinity to 5 with a square bracket. Or you could use parentheses, 3 to 7, something like that. So that's what interval notation looks like. Set builder notation is a little goofy looking. It has some curly brackets on the outside. If you're doing domain, you're going to have an x value, because what this says is all the x's such that you're going to draw a bar, and you could write an inequality. Negative 2 is less than or equal to x is less than or equal to 5. That's an example of set builder notation. We're not going to use set builder notation that much in this class, but it will come up a little bit today. But we're going to be mostly using interval notation when we do domain and range from a graph. So let's take a look here. So as example 1, we have a function g of x. Now from this graph, we are going to find the domain and range. So to start, it says determine the minimum and maximum x values on this graph. Remember, the x values always go left to right. Those go along the x-axis. So I'm going to use my highlighter here. I'm going to highlight at my smallest x value to my biggest x value. We're going to figure out where that falls. So the minimum x value is 1, 2, at negative 3 here. So that's my minimum x. And my biggest x, my maximum, is at 1, 2, 3, 4, 5, 6. Since this graph is continuous, meaning I can trace it without picking up my pencil, and there are endpoints at either end, my domain is every x value in between negative 3 and 6. So using interval notation here, I'm going to say my interval is from negative 3 to 6. Those are all the x's in between those. And because there are full closed dots on either end, I'm going to put a square bracket around that interval. So what that says is this illustrates that the domain goes from the smallest x value to the largest x value on a graph. Now let's talk about y values. I'm going to switch my color here. So I go to my smallest y value. That is the lowest point on your graph to the very highest point on your graph. The y's go bottom to top. All right, so the smallest y value here, this value is down at 1, 2, 3, 4, negative 5. And the highest y value is up at 4. So again, because this graph is continuous, I have every y value in between those two green lines. So that means every y value in between negative 5 and 4. And again, because there are closed dots there, I'm going to put square brackets around my interval. So like we just talked about, the graph that we just did, and most of our graphs in our class, is continuous. That means that we can put our pencil on one end and trace the whole thing without picking up our pencil. All right, so let's go on to the next one. So example 2, I'm going to darken in these dots. You might want to do that on your paper as well. So this graph is the exception to the continuous graph. This one is not considered continuous because if I put my pencil on this dot, there is no way to get to the next dot without picking up my pencil. So it's not continuous. So the first thing we're going to do is we're just going to list the ordered pairs of the points that are on the graph. So this first one, this bottom one here, is at -5, -3. The next one is at -3, 3. We have a point at -2, 5. And finally, the last one here is at -1, 3. So remember, first we want to ask if this is a graph of a function. So you can either use the vertical line test and think that if I draw a vertical line through any of these points, it does not cross through the graph more than once, so it is a function. Or you can look at the ordered pairs and notice that none of the x values repeat themselves, so it would be a function here. Now remember, our domain is with x values, and the range is with y values. So when I have a set of ordered pairs, I want to list out, like this, all of the x values, and only those x values. I can't do interval notation this time, because interval notation means absolutely every single number between -5 and -1. And that's not what we have here. We have only very specific x values. So here you're going to use the set builder, where you have to do your curly brackets. For domain, we're going to put an x and a bar. That means the x's where here x can only be equal to -5, -3, -2, and -1. Those are the x values from the points that we found. Now the range is going to be very similar. You're going to start with your curly brackets, but this time you use the letter y, such that. And we want all the y values from these ordered pairs. So -3, 3, 5, and then this last one has 3 again. Since I already wrote 3 here, I don't have to list it. So you're only going to use set builder notation for graphs when you have a bunch of points. Alright, let's look at the next one here. This is multiple choice. It says some functions have domains and ranges that stretch to infinity. Now it's hard to see on this graph, but there are actually arrows on the end of the graph. I would darken those in on your paper. Now when I have an arrow, that means your graph goes on forever and doesn't stop. So problems like this, you always want to look for the arrows on the graph. Now let's start here with domain. Domain goes left to right. Because I have an arrow on the left part of my graph, that means that this graph is going to the left forever, towards -infinity. The arrow on the right over here is also going forever and ever towards positive infinity. That's going left and right that way. Well, remember, when we do interval notation with infinities, we put a parenthesis and we'll put a comma in between. And I see that domain right over here. This is multiple choice in that problem. So let's make sure the range matches, but that's the only domain that has infinities. So our range is always from bottom, the lowest y value, to the top. Well, my lowest y value here is at -4. So you say, okay, I start at -4 and there's a closed dot there, and my graph goes up because of these arrows forever, which means it's going up to infinity. Bless you, which does match the domain in number 3. So domain and range can have arrows and they can go to infinity. Now we're just going to finish with a bunch of examples here. Right, if you need to, take a highlighter out or colored pen or something. Domain, remember, always goes from left to right. So if you need to, draw a line at the left and a line all the way at the right. If it's a continuous graph like this, then you can do interval notation. Farthest to the left, I'm at -1. There's a value there, so I put a bracket, -1. and I go all the way up until the x of 5. That would be your domain. Now my range, I always start on the bottom. My lowest y value here is at -3. There's a closed dot there, so I put a bracket, and I go all the way up to y equals 3 at the top with a bracket. Now we have to decide, is this graph a function? Well, think about the vertical line test. If I draw a vertical line here, it crosses twice, so it is not a function. On B, same kind of thing. Let's start with our domain, left to right. This is my farthest to the left value. That's at 1. There's a closed dot there, so it's a square bracket. And all the way to the right is at 5, which also gets a square bracket. Now my range starts at the bottom. My lowest y value here is at 0, where there's a closed dot. The highest y value is at 6, which also has a closed dot. Now to decide if this is a function, we're going to use the vertical line test. Anywhere I go, I only cross one time. So yes, that second graph is a function. Third one here. All right, let's start with our domain. I go from the left, where my leftmost x value is at 0. That gets a bracket. But notice on the right, there are 2 arrows that go to the right forever. That means your graph stretches to infinity, and infinity always gets a parenthesis. Now my range, this bottom arrow is going down forever, which means your range is stretching from -infinity, down low, all the way up forever to +infinity. Get parentheses with infinity. Now we need to decide if this is a function. So we do the vertical line test. If I draw a line, it goes through twice, so this is not a function. All right, a couple more here. Let's do a function first this time. I draw a vertical line, it only crosses once. So yes, this is a function here. Now let's talk about domain and range. I start on the left, going this way. Notice there's an arrow on the left, which means your domain goes to the left forever to -infinity, and then it also goes to the right forever to +infinity. When I do the range, I start at the bottom. Notice there are arrows on the bottom, which means you are going down to -infinity forever. You are stopping, though, when you get up to 4, so that gets a square bracket. All right, on this graph, there are arrows on both ends. It is a function because it passes the vertical line test. And for D, because the arrow goes to the left and the arrow goes to the right forever, your domain is from -infinity to infinity. Same idea with the range. The arrow's going down forever and it's going up forever. So your range is from -infinity to infinity, or all real numbers. All right, the last one here. This is not a continuous function, so this is where you're going to put the squiggly brackets. All right, so our domain is all the x values of those points. So if you need to, list out the ordered pairs. 1, 3, 2, 1, 3, -1, 4, 2, 5, 0, and 6, 6. Once you list those ordered pairs, you are just going to be looking for the x values of those ordered pairs. That's going to go after the bar in your set notation. The only x values in this domain are 1, 2, 3, 4, 5, and 6. Now you cannot put an interval there because if I wrote that from 1 to 6, that would mean 1.5 and 2.2, which are not on this graph. So you can't do the interval. For the ranges, you start the same way. You have the y with the bar. This time, you write all the y values that are in your ordered pairs. Y equals 3, 1, -1, 2, 0, and 6. Finally, this graph would be a function because it passes every vertical line that it goes through. All right, there are 2 practices on domain and range. If you need help, there's going to be a video on those practices with the keys posted on campus.